So the first thing we want to do here is we're going to determine which point is which here. So it says that 3x plus 2 is the red graph, and negative 4x plus 5 is the blue graph there, okay? All right, so here I want to look for all of the x values for which 3x minus 2 is greater than negative 4x plus 5. So I'm looking for when the red graph is greater than the blue graph. So I just want to look for where the red graph is above the blue graph. And if I go over here and I see, it looks like starting at 1 and on, this red graph is greater than the blue graph. But I don't want to include actually 1 because that's where the two graphs touch each other. So I just want it to be strictly greater than. So the answer there would be x is from 1 to infinity. Okay. The next one I'm looking for where the red graph is less than or equal to the blue graph. Okay, so if I want the red graph to be less than, that's when the red graph is below, the y values for the red graph are below the y values for the blue graph. So it looks like, and I also want to include where they're equal. So that's going to start at 1. Well, it's going to go from negative infinity to 1. And here I want to include the 1 because I have the equal to there. And so I know that the graphs are equal at 1. And then again here, on part C, I want to find where the red graph is equal to the blue graph. And so that's going to happen at the intersection. So there's only one point there where they intersect, and that is at x equal 1. Okay, the next one, write the equation in slope-intercept form that is parallel to that line and passes through that point. Okay, so for the first part, first of all, we would need to find what is the slope of this line here. So let's find the slope of this line here. So I'm going to go over here. I have 4x minus 5y equals 2. I'm just going to write it in slope-intercept form. So we'll arrange it around. We'll add that 4, or subtract the 4x from both sides. And then we'll divide everything by negative 5. Well, when I divide negative 4 by negative 5, I just get positive 4/5 plus 2/5. Minus 2/5, because I got a negative sign there. Okay. Minus 2/5. There we go. Okay. And so I can see the slope of this line that I'm looking for is 4/5. Okay. And then now I want to write the equation of the parallel line. So I know parallel lines have the same slope. So I want to write the slope parallel line has slope, same slope, m equal to 4/5. Okay. And so, and I want it to go through the point 20, negative 13. So I'll just use point slope form. Okay, and I want to plug in my point, 20, negative 13. So I'll have y minus negative 13 equals 4/5 x minus 20. And I want to write it in slope-intercept form, so let's do that. So I have y plus 13 equals, when I do 4/5 times x, that's just 4/5 x, minus, and when I do 4/5 times 20, I get 16. Okay, and I can subtract that 13 over, and I get negative 29. And so that is my parallel line. Next, I want to write the equation in slope-intercept form of the line that is perpendicular to that line. So what do I know about perpendicular slopes? So that means the slope of my perpendicular line will be m equals negative 5/4. Okay, so the slope of the perpendicular line would be the negative reciprocal of the slope of the line it's perpendicular to. All right, so then again, I'm going to use point slope form. So y minus y1 equals m times x minus x1, and I'll use the same x1, y1 there. All right, and so I get y plus 13 equals, and then when I distribute this to both of those, I'm going to get negative 5/4 x, and then I'll have a plus, let's see, 20 divided by 4 is 5, 5 times 5 is 25, 25 there. And then I can subtract the 13 from that, and I'll get y is equal to negative 5/4 x, and then 25 minus 13 is plus 12. And if you're not sure what you've just done there, what you can do is graph all of those things in your calculator and just see if it looks like it's going through the right points and everything. Now you have to be a little careful on your calculator because it does have a rectangular screen, and so if you're trying to look to see if it's perpendicular, it might not look exactly perpendicular because the screen is kind of smushed in the y direction. So don't worry about that. If it doesn't look quite perpendicular, it may still be correct. All right, so let's look at another one. So the next one says, at a parking garage, the cost of parking, the charge for parking is a flat fee of $2 plus $1.50 per hour. Now I want to write a linear function to model the cost of parking for t hours. All right, so here we go. So we'll say P of t is equal to, well, we've got to pay that $2. Oh, whoops. Oh, I had an extra 0 there. Okay, so we got to pay that $2. And then, oops. So that's $2. And then we want to pay $1.50 times the number of hours there. So that gives me the equation. And then I want to evaluate P of 1.6. Okay, so P of 1.6 means I'm going to take the $2 plus the $1.50 times the 1.6 hours. And so I get 4.4. And the units of that, again, the P gives me the charge, right? So the units of that are dollars. And so what is the meaning of that? So that is the charge for parking for 1.6 hours is $4.40. And there we go. Number 19 says the table gives the average gestational period for select animals. That's how long they're pregnant, I guess. The poor horse. Okay, so the table. So let's see here. What's the question? Is there a question there? Okay, I peeked ahead to the next page, and it seems like it's wanting us to do the least squares regression line. Okay, so we're going to go to our calculator to Stat, and we can go to Edit, and I can edit my list here. I'm going to plug in these things here. So 33, 57, 109, 148, 337. Oh, did I miss one? 1, 2, 3, 4, 5. Okay. And then I've got 7, 9, 10, 12, and 23. And so I'm going to go ahead and do a linear regression. And it looks like my linear regression is the A is 0.05189953, and the B is 5.100714. I wonder how many decimal places we need here. So we'll have y is equal to, that's my slope, ax plus b. So y is equal to 0.05189 x plus 5.100714.